Hey, one of the things that we need to be able to do is estimate a square root. And what I mean by that is we need to be able to look at something like the square root of, let's just pick the square root of 6. Now, the square root of 6 is, we need to be able to figure out an approximate rational number, an irrational approximation, so that we can compare this to other numbers, or we can at least get really kind of close to what it is. And the way that we're going to do this is we're going to look at other numbers that that we know the square roots of. Now, and you've got to remember this is an estimation, and many of us are not very comfortable with estimations of things like this. And it's just because we're not familiar with them. We think that there's some perfect answer for everything, and then we get wrapped around the ideas, well, is this good enough? Is this good enough? Well, think about if you were making cookies and every cookie had to have 8 chips in it, or we were hoping that every cookie had 8 chocolate chips in it. And we're making cookies and oh man, we're getting everything right. And, oh, they're the perfect size. And then we get to the last cookie. And we're just sitting there scraping the bowl, and we're like, oh, we're gonna get a full cookie here. I mean, what's up? And then we put it in our little scoop, and we, chink, and it hits the pan or the sheet. And it's not gonna be just like all the other cookies, because it's a little smaller, but it's close. But it's not as big, and it might only have 6 or 7 chips in it instead of all 8 of the chocolate chips that we wanted. But it's still a cookie, and it's close enough. And if you needed to count the number of cookies you had and you counted that cookie, nobody's really going to care. So it's a cookie. So when we're looking at this and you're like, well, did I take it far enough? All you probably need is 1 decimal place. But a lot of us are going to think that we need to take it much, much farther. I'm also going to use something here called interpolation, which is an averaging between 2 numbers. If I have one number here and another number here, and there's something in the middle that I need, I might just go halfway. And if it's really close to down to the bottom one, I might go 0.9. And if it's really close to the top one, I might go 0.1 or 0.2. These are just guesses. They're educated guesses, but they are just estimations, all right? So let's mark the ones that we know. I know that the square root of 1 is 1. And I know that the square root of 4 is 2. And I know the square root of 9 is 3. So if we look at this, there are 2 numbers here that are between the square root of 1 and square root of 4. So the square root of 2 is going to have to be between 1 and 2. And then if you were to say, well, okay, since it's between them, let's just make it 1.5. Well, that's not a good idea, because halfway between 1 and 4, if we look on a number line, and we look, here's 1, and here's 4. Halfway would be right here. This would be 2.5, would be halfway between those. And 2 is not halfway between this one and this one. So I can't just throw 1.5 because 3 is between there as well. Otherwise, if we were comfortable with putting 1.5 for the square root of 2, we would also put the square root of 3 at 1.5 because it's between those 2 numbers. And that doesn't make any sense, because if we look down here at the 4 and the 9, well, 5 is between 4 and 9. So let's make this one 2.5. Well, this one's between, so let's make that one 2.5. It's not halfway, so we're not going to do that. It is, however, a little less than halfway between 1 and 4, and a little less than halfway between 1 and 4. Maybe this is 1.4. And then 3 is a little farther than halfway. So since it's farther than halfway, we're going to use, maybe instead of a 1.5 here, I'm going to put a maybe 6. All right. And then if I calculate that, if I, hey, what's the square root of 2? Well, it actually is 1.41 is the next digit. Now the square root of 3, when I do that, oh, it's 1.7. Oh, well, I was close. It was 1.6. And if I was comparing these two, I would know that that was 1.6. If I need to be a little more exact, instead of just estimating them, right here, get a calculator, all right? Now, the same, so we're saying that the square root of 2 is approximately 1.4, and the square root of 3 is approximately 1.6. Well, what does that say between the 5, 6, 7, and 8? Now, these are just the real close ones. I'm going to show you one that's much farther away here in just a minute. There are 1, 2, 3, 4 numbers between the 4 and the 9. So halfway is right here. So I would say that the square root of 6 is a little less than halfway between 2 and 3. And halfway between 2 and 3 is 2.5. So maybe I would say that this is maybe 2.35 or 2.4. So I'm going to call this 2.4. The square root of 6 around 2.4. And then I'm going to split the difference here too. How far is it from 2.4 to 2? Let's call this 2.2 because that's halfway and this is halfway. So we're looking at the square root of 7 is a little more than 2.5. So maybe this is 2.6, 2.7. And the square root of 8 is going to be a little closer to 3 than 2.6 is. So maybe it's about 2.8. All right. So when I check those, let's just put that into my trusty calculator. Hey, this is really 2.24. And the square root of 6 is 2.45. Man, I was close to that one. I was 5/100ths off, just guessing that it's going to be a little less than half. The square root of 7 is 2.65. So that was close enough. And then the 8, what's the square root of 8? Square root of 8 is 2.83. I'm 3/100ths off, just guessing to where that this is really close to 3, but it's not 3. And it's closer, it's just close. So it'd be 2.9 or 2.8, and I'm 3/100ths off, okay? And then if I was gonna make an estimation of my square root of square root, and then the square root of 10, well, it's gotta be just a little more than 3. So let's go, I don't know, maybe let's just go 3.17, all right? Now, we're probably never going to have to go to that second digit, but I'm just trying to be fancy here. And the square root of 10, it's 3.16. I was 1/100th off just by throwing my ideas out there, and I'm 100th off. Now, if I was going to be comparing two numbers and I was 100th off and I needed to be that careful, I would certainly find a calculator and figure out what the square root of 10 is. Or what I could do is figure it out manually, which long division and averaging a long division. And that's what I had to do when I was a kid because we couldn't afford calculators. We'd just gotten done. I think paper was new at the time. So it was just a tough time to be a math student. Tougher than it is now anyway. But that's what we're really doing here is we're trying to estimate what square root might be. So let's look at something else. What about the square root of, the square root of 37? Woo! So what I'd do is I would find perfect squares around the number 37 that I know. So let's go with 36 because 36 is 6 times 6. So I know that 36, the square root of 36 is 6. And then 37, 38, 39, 40, 41, 42, 43, 44, 45. I'm running out of room, dude. 46, 47, 48, 4-9er. Yes, there was a 9er in there, and yes, we're on walkie-talkies. And the square root of 49 is 7. All right. Whew, man, I'm out of breath. So look how far, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 numbers between 36 and 49. So there are 12 numbers in here that if I was to look at the middle one, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So the middle is right here. So really, if we're looking for a square root of something that is between 6 and 7, here's where the 6.5 sits. So I might say that this one was maybe a 6.4, maybe a 6.3, 6.2. We don't have enough for the 6.1. So I'm going to put a 6.1 here maybe, and then maybe I'd put a 6.2 here, and then let's just leave that there, okay? And then I would put the 48, I would put the square root of 48 really close to 7. So maybe a 6.9 down here, and a 6.8, and a 6.7, and a 6.6. All right, so we're getting all those estimations out of there. Now there's two numbers here, so maybe this is a 6.85 and that's a 6.9, something like that. But what I want to do here for sure is put the square root of 37 really close up by the square root of 36. And since the square root of 36 is 6, the square root of 37 must be really close to 6.1. So square root of 37 is 6.08. So even with this weird little estimate, I was 2/100ths off. And if I'm going to multiply anything by 2/100ths, I'm going to be close enough, okay? I'll do one more with you. One more. We're going to do one more. All righty. I'll just make one up here. Make one up. Let's go with the square root of, excuse me, 105, square root of 105. Well, I'm going to pick the two squares, the two perfect squares that I know are close to 105. So my first one is 100, because I know the square root of 100 is 10. And then we've got 101, 102, 103, 104, 105, 06, 07, 08, 09, 110. What's my next square? It's 121. So I've got to go all the way to 121. So if I'm going to estimate this thing, and I want to estimate this one right here, and I've got 1, 2, 3, 5, 6, 7, there's 10, and then 11. So there's 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, and then 121. This is my next square because the square root of 121 is 11. This is my next perfect square. So look how many numbers there are between these. There are 20 numbers here. So let's look at where would my halfway be? Well, my half would be right here. So this is my halfway mark, okay? My halfway mark. So I would say that this is 10 and this is 11. I would say that this right here would be 10.5. So maybe one of these two matches the 10.5. And then if I look back, 1, 2, 3, 4, 5, 6, 7, 8, 9. So my midpoint right here, I need something halfway between 10.5 and 10. And so let's go with 10.25. All right. So this is an estimation again, but we're looking at 105, and I want the square root from it. And it's 10.25. Can you believe it? Darn, I'm good. All right. Anyway, 10.25. And it's just because, hey, how far was it? Well, I had a 10 over here and an 11 over here, and I had 10 places, or I had 20 places between them. So I looked at how far was 105. Well, 105 was 25% of the way. So I took 25% of 1, which is 0.25, and I just added it, and I nailed it. All right. Now that's a business calculator, and it rounded it to 100 to hundredths, but still, I'm just messing around trying to figure out, well, it's probably close to this. So if you guys are dealing with this stuff and you're getting close, it's good enough. It's that last cookie that comes out of the mixing bowl and gets onto the cookie sheet to be cooked. It's a cookie, all right? So if you get close enough with this, and you look at, if you're comparing or ordering numbers, and you need a rational approximation of an irrational number, there it is. It's a guess. If you get wound up around, oh no, I don't know if my guess is good enough, grab your calculator and do it that way until you get comfortable with it. It's not cheating, okay? It's just a different method. And really, in the end, what we want is you to be able to tell what the number is close to. All right? So this is an extra video. Hopefully you watched it. I do keep track of how many times the videos are watched. These are good for you. See ya.